Hello everyone. So we're here to discuss how to use the product rule and quotient rule. We've already seen the proofs if you watch those videos using first principles, which is really good, exciting. But now it's just kind of the practical use. And there was one on the chain rule as well, so you can look that up if you have a problem with the chain rule. But this is going to assume that you're good with the chain rule. So we know that the product rule, so if we have y equals u of x, v of x, so these are functions of x, then we're saying dy by dx is our v of x, u dash of x, plus u of x, v dash of x. So how do we actually use this? Let's do some examples then. So y equals x squared all times x cubed plus 3x to the power of 10, let's say. So we're starting with a tough one. Okay? What we're going to do is we're going to assign one of them to be v and one of them to be u, because this is a product rule situation. I have a product of two functions. Two functions are timesing each other. Notice that this is all to the power of 10, so I'm going to have to use my chain rule thing. Now, I don't want us using this formula so much as in like this is u, this is v. I want us to quickly skip past that because once you start using u's and v's, you get loads of variables and you can get pretty tangled up, just like with the chain rule. But we can do one example, but then I'm going to stop doing that, okay? So, u of x is x squared, u dash of x, differentiating x, u with respect to x is 2x. V of x is x cubed plus 3x all to the 10. Now remember, chain rule, to me this reads x to the power of 10. So I get 10x to the power of 9, and then x in the middle differentiates to 3x squared plus 3. Therefore, dy by dx, just following my recipe, I have v, which is here, u dash, which is here. So I've got v u dash, so 2x, x cubed plus 3x all to the 10 plus, and then we've got our u v dash. So u is x squared. We have 10 lots of 3x squared plus 3 from here and here. And then we've got our x cubed plus 3x to the 9 there. And that's finished. Okay, so let's do a little bit more, but I'm not going to split them up anymore in terms of u and v. I think we're going to get the picture pretty quickly. Let's go for y equals x cubed sine 3x squared. So again, we've got a product. We've got two functions timesing each other. This is u, this is v. And I'm going to launch straight into it. So dy by dx is, again, I'm not going to do what I did before and actually write u of x, u dash of x, v of x, v dash of x. I'm just going to do it by saying, right, this thing's going to stay the same. This is our u, so that just stays. And now I'm going to times it by the differential of v. So sine x, remember chain rule, goes to cos x, and then we're timesing it all by the differential of our x, which is 6x, plus. So I know for a product rule, I have one term plus another term, or it might be a minus if it turns out negative here. But I should have two terms. You know you've gone wrong if you haven't got two terms. So this time, v stays the same, so sine 3x squared, and then I'm times it by the differential of x cubed, which is 3x squared. And we're done. One more example then. Let's see if we can do it without reference to the chain rule to the product rule up there. We need to start learning that off by heart. So this time, let's go for y equals tan of 4x cubed all times by sine x then this time. So I've got a product, one thing times another thing. Here's my u, let's say here's my v. I'm launching straight into dy by dx equals u thing stays, so sine x stays, and then v dash is going to be tan x, so tan x goes to sec squared x, all times by the differential of our thing here, which is 12x squared. Plus, remember, we'll always have two terms. This time the v stays, so tan 4x cubed, all times by our u dash this time, which goes to cos x. And we're finished. We could tidy that up somewhat. So 12x squared sine x times by sec squared 4x cubed plus cos x tan 4x cubed. And we're happy. So now we're going to move on to the quotient rule. And as we know that the quotient rule is if y is u of x over v of x, then dy by dx is going to be v squared. So v of x all squared over v of x, u dash of x, subtract u of x, v dash of x. So notice every time v squared v, v squared v. Okay, so do similar to what I did before. So let's go for y equals x squared over sine x. So clearly this is a quotient rule problem. We've got one function divided by another. So I'll do it in one step first. So u of x is x squared. U dash of x then is 2x, just building up all of our ingredients. V of x is sine x, and v differentiated becomes cos x. So what we have then is dy by dx equals, and now we're just filling in our stuff. So v squared on the bottom, this is v, so sine x all squared, and then v comes straight up sine x. And then we're timesing it by a differential of u, which is 2x. Subtract, remember just like the product rule, we've got two terms, and now we've got u of x, which is x squared, and v dash of x, which is our cos x, and it's finished. Let's do another example then. So remember, in shorthand, y equals uv, we're going to get dy over dx is v squared v, so v squared v, u dash minus u v dash. So let's make up another example, and I'm not going to use u's and v's anymore explicitly, I'm just going to do it. So I've got 4x cubed over 3x plus 1 all to the power of 10. So a chain rule again. This is a quotient, one thing over the other, and therefore we can launch straight in. So dy by dx equals, here's my v, and on the top there's my u. So v squared, I've got 3x plus 1 to the 10, all squared is going to make that 3x plus 1 to the 20. And then my v goes straight up. And then I'm going to times it by the differential of u, which is 12x squared. Minus, and this time the u stays, just like before, and we're going to times it by the differential of our v this time. So chain rule, this is x to the 10, which goes 10x, reduce the 1 power by the 9, and then times by the differential of the inside, which is 3. It's not very neat, I'll write that again. So 12x squared, 3x plus 1 all to the 10, subtract 30 times 4, x cubed over 3x plus 1 to the 9, all over 3x plus 1 to the 20. And again, I can clean that up. Literally the last one then. So, we've got our quotient rule, which again I want you to remember off by heart. This time I'm going to go for y equals tan x on the bottom, and let's go for 4x cubed plus x to the 5. So another chain rule problem. So here we've got u, here we've got v. We're going to go straight into it. Dy by dx equals, remember, v squared v. So tan squared x tan. And now we're going to times it by the differential of our u. Chain rule then, this is x to the 5. So this gives me 5x to the 4. Times by the differential of our x, which is 12x squared plus 1. Subtract, let's make that a bit smaller. Subtract, and then we've got our u stays the same this time, so 4x cubed plus x to the 5 And now we're going to differentiate our tan, which is sec squared x. So if I want to clean this up a bit, I've got 5, 12x squared plus 1, 4x cubed plus x to the 4, tan x, subtract 4x cubed plus x to the 5 sec squared x, all over tan squared x, and we're happy. Thanks for tuning in. Make up some of your own. Check it on your calculator. Remember, x equals 0.01 using that differential button. Everything can be checked. Thanks.